noticed that there were some issues with the recording, and I think I know why. So I'm gonna I don't know, I might go back, or I might be lazy and not go back and re-record the old ones. I'll try. And I will get you guys a final exam review like I did for the midterm. I'll put it up on my website. I'll probably just put it under the same tab, like where all the midterm review stuff is. I'll just, like I did the ABC, I'll just keep going and do like D, whatever, yeah. Okay, so let me make sure I can actually see the full board from my computer here. Yeah, there we go. Okay, so what are we doing? We are talking about Bayes' theorem. That's probably going to be the big thing. I should probably not show you the questions in advance. We're going to talk about Bayes' theorem briefly, and we're going to do a lot of work today on general permutations and combinations. So to begin, n choose r, which is the same thing as that, two different notations for the same thing. That's equal to n factorial over r factorial times n minus r factorial. So you use combinations when you don't care about the order of things that are chosen, right? And you read this as n choose r. For permutations, there's no real symbol like that. Permutations are, you might read this as like n pick r. Formula for that is n factorial over n minus r factorial. And so that's what you would use when you do care about order. So this one is order doesn't matter. Well, I guess I should say no order, and this one is ordered. Does that make sense? Cool. I'm going to derive an equation, Bayes' theorem, which I think I did, if you were in my, like when I was covering on Monday for Mihai, I think I did that. But I didn't actually ever call it Bayes' theorem. I don't know if Mihai did it and called it Bayes' theorem, I'm not sure. But say you wanted to figure out what the probability of A given B is. And let's say that you know information about the opposite of that, B given A. Right, so how do we relate A given B to B given A? What we do, right at the definition of A given B, we get probability of A and B, or intersect B, over probability of B. Right? Now, what I'll do is I'll write that probability of A given B as the probability of B given A times probability of A. You agree I can write the top like that? Awesome. And then the bottom, I can write probability of B as probability of B and A plus probability of B and A bar. Right? So then from here, I can expand each of those two bottom terms. I'll get probability, top stays the same, B given A times probability of A over the probability, so this term here is going to become B given A times probability of A. And then this term here is going to give me probability of B given A bar times the probability of A bar. So this is the Bayes' theorem. It sort of is just probability of A given B equals this. It just sort of relates A given B to B given A. It's not quite as easy as like you might think. Maybe like you might think it's like 1 minus or something. It's more complicated. So to do this, you need two pieces of information. You need probability of B given A. You need the probability of B given A bar, and you need the probability of A. And of course, you can figure out what the probability of A bar is because probability of A bar is going to equal 1 minus the probability of A. Right? Awesome. I think that's all I wanted to go through. Any questions before we move on? All good? Cool. So let me stop the recording.